Previously, we have seen how to draw the graph of a linear equation, and that too we done it by finding two solutions of the linear equation, and then the line joining these 2 points is actually the graph of a linear equation. But if we say that we want to draw the graph of a line that is parallel to the x-axis or a line that is parallel to the y-axis, then how to draw such lines? What are the equations of such lines which are parallel to the x-axis or the y-axis? X-axis and y-axis together are called as the coordinate axis. So that is something we are going to study in this lecture. We are going to see what are the equations of lines that are parallel to the x-axis and the y-axis and how to draw such lines. So now let us say that this is the coordinate plane. This represents the x-axis and this represents the y-axis. Also, the points on the right hand side of the origin on the x-axis are all positive, and the points on the left hand side of the origin on the x-axis are all negative. Similarly, if we consider the y-axis, then all the points above the origin are positive, and similarly all the points below the origin are negative. Now first of all, we are going to look at what is the equation of x-axis and what is the equation of y-axis. So first of all, let's consider a few points. Let us say that this is a point, the coordinates of which are 0, -2. Let's consider this point. What are the coordinates? 0, 1. For this point, the coordinates are 0, 3. And lastly, what are the coordinates of this point? The coordinates are 0, 6. So all these points lie on the y-axis. Also, what we observe here is that every point is of the form 0, y. So all these points are of the form 0, y, where the x coordinate of all these points is equal to 0. So all the points 0, -2, 0, 1, 0, 3 and 0, 6 have the x coordinate equal to 0, and all these points lie on the y-axis. So what we can say? We can say that the equation of y-axis become x equal to 0. So the equation x equal to 0 represents the y-axis, as all these are the solutions of this equation x equal to 0. We can have any value of y, but the x coordinate should always be equal to 0. So the equation of y-axis becomes x equal to 0. Now let's see the equation of x-axis. For that, again we are going to consider a few points. Let us say this is one of the points. The coordinates of this point are -2, 0. Similarly, if we consider this point, the coordinates of this point are 1, 0. If we consider this point, then the coordinates become 4, 0. And if we consider this point, the coordinates are 7, 0. So all these points actually lie on the x-axis. And the common feature is every point is of the form x, 0. Or we can say that the y coordinate of every point is equal to 0. Thus, we see that all these points which are -2, 0, 1, 0, 4, 0, 7, 0 have the y coordinate equal to 0, and thus we can say that the equation of x-axis is y equal to 0. So the equation of x-axis is y equal to 0 because the y coordinate of each and every point on the x-axis is equal to 0. Thus the equation of y-axis is x equal to 0 and the equation of x-axis is y equal to 0. Now let us say we have the equation x minus 5 equal to 0. Now let's take an equation as x minus 5 equal to 0. Now the solution of this would be x equal to 5. Now this equation has one variable x, and so it has a unique solution which is x equal to 5. Now the same equation could be written in two variables as 1 into x plus 0 into y minus 5 equal to 0, because 0 into y is actually equal to 0. So we can write this equation as 1 into x plus 0 into y minus 5 equal to 0, and thus this becomes a linear equation in two variables. Now each point is of the form 5, a. In this equation we have every point of the form 5, a, and is actually the solution of the above equation. So every point of the form 5, a is actually the solution of this equation. Your a is any real number. If we take different values of a, we get different coordinates, but all these points are actually the solution of this equation. Now how to represent the equation x minus 5 equal to 0 on the coordinate plane? So let us say that once again this is the coordinate plane, this being the x-axis and this being the y-axis. Now 5 comma a is the general solution, we have seen it earlier. Now we are going to take different values of a. So if we take a as equal to minus 2, minus 1, 0, 1, 2, 3, therefore we can take different values of a because a is a real number. And so let us say that we have taken the values as minus 2, minus 1, 0, 1, 2, 3. So the solutions would be 5 comma minus 2, 5 comma minus 1, 5 comma 0, 5 comma 1, 5 comma 2, 5 comma 3, and so on. So the first point is we have taken a equal to minus 2. So this is 5 comma minus 2. The second point is 5 comma minus 1. So this would be 5 comma minus 1. For the third, a is equal to 0 and thus this represents 5 comma 0. Next we take a to be equal to 1. So 5 comma 1 is represented by this point. Similarly, we take a equal to 2 and this represents the point 5 comma 2. And also this point has the y coordinate as equal to 3. So this point is 5 comma 3 for a equal to be 3. Thus we see that these are the points which we get if we take different values of a from minus 2 to 3. Now if we draw a line passing through all these points, then we see that this line is at a distance of 5 units and is actually parallel to the y-axis. So this line is at a distance of 5 units from the y-axis and is parallel to the y-axis. So the equation x equal to 5 represents this line. Why? Because we see that the abscissa or the x coordinate of each and every point is equal to 5. So every point on this line is of the form of 5 comma a, where we can have different values of a, and this line x equal to 5 represents a line that is parallel to the y-axis and is at a distance of 5 units from it. This is a line which is on the right hand side of the y-axis. Similarly, we can have a line parallel to the y-axis on the left hand side, but this time the equation would be x equal to minus 5 because now the x coordinate of each and every point lying on this line would be equal to minus 5. So this represents a line parallel to the y-axis and at a distance of 5 units from it. Now let's consider one more example. We take the equation as 5 minus 3 equal to 0. Now this is again a linear equation in one variable. So the solution of this equation would be y equal to 3. So this has a unique solution which is y equal to 3. Now we can convert this one variable equation into two variable equation as we can write it as 0 into x plus 1 into y minus 3 equal to 0. So we have converted this one variable linear equation into two variable linear equation. Now each point is of the form of b comma 3 and is the solution of the above equation. Here b is a real number. Here we see that the solution of this is y equal to 3. So every point of the form b comma 3 would be a solution, and here important thing is b should be a real number. Thus y equal to 3 is a line that contains all the points of the form b comma 3. Now let's see how this equation looks in the coordinate plane. So again we have the coordinate plane with this as the x-axis and this as the y-axis. Now b comma 3 is the general solution we have seen. Now for y minus 3 equal to 0, b comma 3 is the general solution, and let us take different values of b such that b is equal to minus 2, b is equal to minus 1, b is equal to 0, b is equal to 1, b is equal to 2, and b is equal to 3. So depending on the different values of p, let's plot these points on the coordinate plane. So the first point is minus 2 comma 3. Your b is equal to minus 2 and the y coordinate remains 3. The second point is minus 1 comma 3 because again b is equal to minus 1. If we take b to be equal to 0, then we get this point which is 0 comma 3. If we take b to be equal to 1, we get this point which is 1 comma 3. If we take b to be equal to 2, we get the point 2 comma 3, and if we take b to be equal to 3, we get the point as 3 comma 3. Now for different values of b, we get such kind of points. Now if we draw a line joining all these points, we see that this line would be at a distance of 3 units from the x-axis. Thus the line joining all these points is parallel to the x-axis and is at a distance of 3 units from it. So what we can say that the equation y equal to 3, this line represents the equation y equal to 3 and is parallel to the x-axis and at a distance of 3 units from it. Similarly, we can have a line parallel to the x-axis and at a distance of 3 units from it here below the x-axis, and the equation of this line would be y equal to minus 3 because now the y coordinate would be equal to minus 3. To sum up, we can say that y equal to 3 is a line that is parallel to the x-axis and at a distance of 3 units from it. Now let's see some of the important remarks. The first is, for a line that is parallel to the x-axis, the equation for such a line is given by y equal to b, where b is some constant. Notice that b is the value of the y coordinate of any point on the line. So if we have to write the equation of a line parallel to the x-axis, then it can be written as y equal to b. Here b is the value of the y coordinate for all the points on the line. Let's try to look at graphically. Let us say that this is the coordinate plane. Now let's take b to be equal to 2. If we take b equal to 2, then the equation y equal to b becomes y equal to 2, and this equation would be this one. Thus this represents y equal to 2. And again we see that for all the points on this line, the y coordinate is equal to 2 and is constant. And because of that, this line is parallel to the x-axis and is at a distance of 2 units from it. So in general, we can say that any line that is parallel to the x-axis has the equation of the form y equal to b. Here b is a constant. Also b represents the y coordinate of every point on this line. The next is, for a line that is parallel to the y-axis, if we want to have a line that is parallel to the y-axis, the equation for such a line would be x equal to a. Here a is some constant. Notice that a is the value of the x coordinate of any point on this line. So what we can say that if we want to write the equation of a line that is parallel to the y-axis, then the equation of such line would be x equal to a. Here a is some constant. Also a is the value of the x coordinate of any point on this line. So now let us say that a is equal to 4. Now if we assume a to be equal to 4, then the equation x equal to a would be x equal to 4 is x equal to 4. Here we see that the x coordinate of every point on this line is equal to 4. Also we observe here that this line is parallel to the y-axis and is at a distance of 4 units from y-axis. So now we know how to write the equation of x-axis, y-axis, or any line which is parallel to the y-axis or the x-axis. So let's try to apply this knowledge in some problems. Let's solve this problem. It says that solve the given equation 3x minus 4y plus 4 is equal to 2x plus 6y minus 10y plus 6, and represent the solution on number line and the coordinate plane. So in this problem, what we have to do is, we have been given an equation and we have to represent this equation on the number line and on the coordinate plane. So let's look at the solution of this. The given equation is 3x minus 4y plus 4 is equal to 2x plus 6y minus 10y plus 6. Further, we can simplify this to 3x minus 4y plus 4 equal to 2x minus 4y plus 6. Again, this could be further written as 3x minus 2x equal to 6 minus 4. This gives x and this gives 2. So what we get is x equal to 2. So this equation transforms to x equal to 2. And we know that x equal to 2 represents a line that is parallel to the y-axis. So first we have to represent x equal to 2 on the number line. Let us say that this is a number line, this being the 0 of the number line. Numbers on the right side would be positive and numbers on the left hand side would be negative. Now we have to represent x equal to 2. This represents the values of x, and this point would be actually equal to x equal to 2. So this point actually represents x equal to 2. So on the number line, this is the way to represent x equal to 2. Now we have to represent the same equation on the coordinate plane. So this is again the coordinate plane, with this being the x-axis and this being the y-axis. So we have to represent x equal to 2. We know that x equal to 2 is nothing but a line that is parallel to the y-axis and is at a distance of 2 units from the y-axis. Also, the x coordinate of each and every point lying on this line would be equal to 2. Therefore, this line is x equal to 2. Thus, the equation x equal to 2 is represented by this line. This line is parallel to the y-axis and is at a distance of 2 units from the y-axis. So very easily we have solved this problem. Let's look at another problem. Draw the graph of the following linear equation in the Cartesian plane. The equation is 5y plus 6 equal to 3y plus 12. So now we have been given an equation. We have to draw the graph of this equation. So again, the given equation is 5y plus 6 equal to 3y plus 12. So the given equation to us is 5y plus 6 equal to 3y plus 12. Further, this could be written as 5y minus 3y equal to 12 minus 6, bringing 3y to LHS and 6 to the RHS. This further gives 2y equal to 6, and this could be written as y equal to 3. Thus this equation reduces to y equal to 3. Now we have to draw the graph of this line y equal to 3 in the coordinate plane. So again, this is the coordinate plane with this as the x-axis and this as the y-axis. And we have to represent the line y equal to 3. We know that y equal to 3 is a line which is parallel to the x-axis and is at a distance of 3 units from it. So this line we see that is at a distance of 3 units and is parallel to the x-axis. So this dotted red line represents the equation y equal to 3. So the y coordinate of each and every point on this line is actually equal to 3. Let's try to solve one more example. Write the equation of the line that is parallel to the y-axis and is passing through the point. First is 2, 2, second is -1, 0, and the third is 4, -2. Also draw the graphs of the respective equations. So in this problem, what we have to do is, we have to write the equation of a line that is parallel to the y-axis and it passes through the following points. The first is 2, 2, second is -1, 0, and the third is 4, -2. Also, we have to draw the graphs of the respective equations. So let's try to solve this problem. We have to draw a line parallel to y-axis. Now this is the coordinate plane. This is the x-axis and this is the y-axis. Now the first is, the line is parallel to y-axis, passes through the point 2, 2. Now we also know that any line parallel to the y-axis will have the x-coordinate as constant. This is equal to 2. The x-coordinate of this point is equal to 2. So the line which is parallel to y-axis and which passes through this point should have the x-coordinate always equal to 2. And thus we can say that the equation is of the form of x equal to a. Your a is equal to 2, and so the equation would be x equal to 2. Thus a line parallel to y-axis and passing through the point 2, 2 is x equal to 2. Now let's try to represent it in the coordinate plane. This would be, so this line, which is the dotted red line, is x equal to 2. It passes through the point 2, 2 and is parallel to the y-axis. And also the x coordinate of each and every point is equal to 2. Now the next is -1, 0. So we have to draw a line parallel to the y-axis and such that it passes through the point -1, 0. Now the equation of this line would be of the form x equal to a, and your a is equal to -1. Thus what we get is the equation of line parallel to y-axis and passing through the point -1, 0 would be x equal to -1. Now let's try to represent it in the graph. This dotted red line is actually x equal to -1. So this is a line that is parallel to the y-axis and it also passes through the point minus 1 comma 0. Minus 1 comma 0 is this point, and this line passes through it. So x equal to minus 1 is the equation of line which is parallel to y-axis and passes through the point minus 1 comma 0, and this represents the graph of x equal to minus 1. Let's look at the third point, which is 4 comma minus 2. So we have to draw a line parallel to y-axis and passing through the point 4 comma minus 2. Again, the equation of line is of the form x equal to a, and here we see that it passes through 4 comma minus 2. Therefore x should be equal to 4, and thus we get the equation as x equal to 4. Thus the equation of a line parallel to y-axis and passing through 4 comma minus 2 is given by the equation x equal to 4. Now once again, let's try to represent it in the graph. This line represents x equal to 4. Thus the red dotted line is x equal to 4, and every point lying on this line has the x coordinate equal to 4. Also, this line is parallel to the y-axis and at a distance of 4 units from the y-axis. So with this we come to the end of our lecture. Here we have studied how to find the equation of a line parallel to the x-axis or the y-axis, and also we have seen how to draw the graphs of such linear equations.